All right, we're going to learn how to add, subtract, and multiply complex numbers. And adding and subtracting is pretty straightforward. When we add and subtract, if we have two complex numbers, so for example, we have 8 minus I plus 5 minus 4I, that's going to equal 8 plus 5, so we're going to add our real parts, and we're going to add, here I'll put these in parentheses, so we're going to add our real parts and we're going to add our imaginary parts. So we have a negative I and we have a minus 4I. So we'll have 8 plus 5, which is 13, and then we'll have negative I minus 4I for minus 5I. Okay, let's do this again though, but let's subtract. So if we have 8 minus I minus 5 minus 4I, if we were to remove all these parentheses, we'd see that we have 8 minus I, we'd have to distribute the negative, minus 5, and distribute to the minus 4I to give us plus 4I. And basically, all we're really doing here is combining like terms. So that's why we're going to combine our real parts. We'll have 8 minus 5, and we'll have minus I and plus 4I. So just putting the real parts together, putting the imaginary parts together. 3, negative I and positive 4 is just positive 3I. 3 plus 3I. So again, just combining your real parts, combining your imaginary parts. When we have addition, we can just ignore, we don't have to worry about distributing a negative, but if we're subtracting this complex number minus this complex number, then we need to distribute that negative first, and we're basically combining like terms. This problem becomes much like the first one, and then we can just simplify. So that's adding and subtracting. If you wanted to do another one that they have in the books, they have this one that's looks a little different. So they have 13, a real number by itself. They're going to subtract a complex number, and then they're going to add an imaginary part. Now, if you were to rearrange this, you might say, well, isn't this a real and imaginary? Isn't that a complex number? Sure, it's addition and subtraction, and the commutative and associative properties work just the same. But basically, we'll just keep this in the form that it's in this order. We'll go ahead and distribute our negative sign here, 13 minus 2 minus 7I plus 5I. And then we'll combine our real parts, and we'll combine our imaginary parts, and we'll have 11 minus 2I. And that's our final answer there. Okay. And then there's another example in the book. This is on page 105, this one problem here. Page 105 is C, example C from under example 3. And so part C, and then honestly, we should probably do part B also, because they show you what to do when you simplify if you have like a 0B. And so that problem was 7 minus 6I minus 3 times, oops, sorry, that's not right, minus parentheses 3 minus 6I. So you can see this, we've got a minus 6I, this is going to turn to a positive 6I, so we'll have 0 6I's. Okay, so we have 7 minus 6I, distribute the negative, minus 3, plus 6I, and so the imaginary parts will end up being 0I, and we'll have 7 minus 3, which is 4 minus 0I. This simplifies away. 0 times anything is 0, so we have 4 minus 0. And so for this one, we're left with just 4 as our final answer. Okay, so that's a really good set of examples for simplifying or for adding and subtracting complex numbers. Now let's move to multiplying complex numbers. We're going to do some of the examples that are in the text on page 106. Okay, so multiplying. So we have 4i times -6 plus i. And all we're going to do is distribute this. Okay, so we're going to use the distributive property. 4 times -6 is -24i. So we're really treating I just like x, just like any other variable here. So we have -24i, and then we're going to have 4i times I, which is going to yield 4i squared. Well, that's really interesting. What does I squared equal? Let's think about it. If I squared is equal to I times I, right, which is equal to the square root of -1 times the square root of -1, well, when you multiply square roots, wouldn't you have -1 times -1 inside the parentheses, inside the radical here? And so wouldn't that be the square root of 1? And doesn't that actually equal 1? So I squared simplifies to 1. So this is going to be -24i plus 4 times 1. And so that's going to be 4. So that's our real part now. And this is our imaginary part, right? And so we're going to rearrange this and write our final answer as the real minus the imaginary part. So that's kind of our standard way of writing these answers. We want to have A plus or minus B times I for our final answer. And was this a -4? Oh, sorry guys. It's not 1. It's -1. I'm getting confused with my I cubed. We have -1. This is better. So -1 times -1 is -1 squared. And the square root of any number squared equals that number. And so we're going to have this be -1 here, which yields -4 and -4. Sorry about that, if I was confusing there. So I squared is -1. In fact, let's just do a little conjugation here. So we know that I equals the square root of -1. We know that I squared equals the square root of -1 squared, which is -1. I cubed actually equals -1, which is, here, in fact, let me break this down. I cubed is going to be I squared times I, which is -1 times the square root of -1, which is simply negative square root of -1. And I to the 4th equals I squared times I squared, which is -1 times -1, which is 1. And so at the end of the day, we've got these I to the first power, basically, I squared, I cubed, and I 4th, and they follow this little rule that I is the square root of -1, I squared equals -1, I cubed equals negative square root of -1, and I to the 4th equals +1. All right, so that's something you'll get used to using as we do more problems here. Okay, let's do another multiplication. This was part A under example 5 on page 106. Let's do B. So B says 9 minus 2i. 9 minus 2i, just checking the clock here, and -4 plus 7i times this. And so this is going to be one of those situations where we're going to multiply first times first, outer times outer, inner times inner, and last times last. If you ever learned FOIL, we're just going to do that with these numbers. If you learn to multiply binomials a different way, you can use a different method. Okay, But first times first, 9 times negative 4, that's going to be negative 36. Outer times outer, 9 times 7i is going to be 9 times 7, 63i. And then inner times inner, negative 2i times negative 4 is going to be positive 8i. And then negative 2i times positive 7i is going to yield negative 14i squared. So what we'll do is we'll simplify the I squared. That's going to be equal to negative 1. So this becomes negative 14 times negative 1. We'll combine these middle terms, 63i and 8i. That's 71i. 71i. And then we just have negative 36 here. So this minus 14 times negative 1 is plus 14. We have a minus 36. We want to combine those real parts. And so we'll end up with negative 22 here. We'll bring our 71i, that's all positive. And so when we multiply two complex numbers, we generally end up with a single complex number. Okay, just like we did here. All right, so that's multiplying complex numbers, adding and subtracting complex numbers, and that's the major skill set for this unit. But there is a little bit more on complex solutions and zeros. I'm going to make a third video on that.